being able to join us. And we're going to be talking about our experience of teaching engineering lab courses here at Embry-Riddle Worldwide. And as you know, we started the BS in engineering degree in 2016. And at that time, it was one of the first completely online BSc programs in the country. And we received our full ABET accreditation. I think it was 2018. And at the very beginning, there was, as you can imagine, quite some doubt about how we can do the BSc online. And most of the concerns rest upon the ability for us to do labs. And it's not just doing simulation, running software. And one of the criteria in the ABET accreditation is that you provide students with the real hands-on experience working with equipment. And that's something that most of the accreditors and also many people, including our colleagues in Daytona Beach, doubt that we have the capability to do it. So what we have to address is to provide the students with that experience. And in our BSc program, we have different two main concentrations at this point. One is on the mechanical side, and one is on the electrical side. And both Jorge and myself and several other faculty members are on the electrical side, and we feel that with the technology advancement these days, that we can have the hands-on experience for the students, simply because the educational tools, personal portable educational tools that many providers have the ability for the students to have almost the same brick and mortar in-person classroom experience. And so that's what we started to do. If you can go to the next slide, please. Okay, so when we started developing our BSc courses, especially lab courses, and we contemplated on how we can provide that experience. And we do not have a centralized lab, and all the students are working from their home. So the equipment that we want the students to buy needs to be affordable, number one, but also have the support both in hardware and also software for them to complete the lab assignments. And for that reason, the main idea that we have is we want to have one lab kit. And when we started, we sorry, I've lost my word. We focus on this lab kit called MyDeck, if you look at the third line. So MyDeck and also the company lab kit. The idea that we have is that we want the students to buy one kit and we can use it for several courses in the curriculum. And that way, the students can financially invest just one time, but they're set for several core lab courses. And on the other side, and because the students are using the same equipment, same lab kit through several courses, there is no sort of break-in period. And they should be familiar with both the hardware and the software as they move on to, for example, the second course in the curriculum. So we started with MyDeck, and it was very good experience. But COVID started, and the company had a lot of supply issues. And so for 2 or 3 years, the inventory was just not there. So we have to switch to simply the simulation-based labs. And then we just learned that MyDeck was discontinued, and therefore we have to start from scratch again and develop our lab courses based on new hardware that is called the analog discovery. And we're still in the process of redeveloping our lab courses using that hardware. But still, the idea is one lab kit, one lab equipment. Right now is about $300 to $400. but the students can use the same kit for at least 3 lab courses. So they get their money back for that. Yeah. So for these two hardware, the MyDAC and Analog Discovery, they are pretty about the latest educational lab product. And as I said, they're portable. They're multifunctional, which means they can be used as input device, they can be used as output device, and they also have very strong software support. And so they can collect signals, they can plot very nice diagrams. And they also have strong tech support, not just from the company, but also there's a huge online community that can provide assistance when the students have questions. There are abundant tutorials and also applications that students can reference. Next slide, please. So here is just a picture of the hardware that we have in the BSc programs. As you can see, we have the MyDAC. As I said, that's the focus for 3 or 4 lab courses. The bottom two on the left side, that's for the digital logic course. And on the right-hand side, that is for our mechatronics and robotics course. So the bottom line is we ask the students to buy these kits. The most expensive one is, of course, the one on the top. That's right now, it's about $300, $400. But the other two are in the $100 range. So these are the educational expenses the students have to spare. But comparing with other tuitions, I think they're quite affordable, especially when the students know that they can use these equipment for a couple of courses altogether, maybe 20 to 30 labs. Next slide, please. Okay, so now let's move on to the main idea when we develop our lab course. So we have the lab course set, and how do we develop our lab courses? So most of these lab courses have gone through several updates and redevelopments, and we learn from IDD the issues that we have. So we heard a lot of students complaints about the lack of instructional videos, especially on the labs. And in some courses, we're still using YouTube, which are relevant, but they're not exactly the same as the equipment that we use in these courses, but also on the content, they are not the same labs that we're doing in those courses. So students get quite confused, especially with students with no hands-on experience putting things together, and they're sitting at home without their peers or in-person instructors to help them. And so when we redevelop these courses, we have this idea that we have to provide a very structured uh, uh, course with abundant instruction videos help. So this is a screenshot of the latest lab course development. As you can see, there are 3 tabs on the top, and every lab is broken into these 3 phases. The first one is a quick theory review and give the students an idea what the objective is, what they have to analyze theoretically on the lab results. And the second phase in the lab process is what we call the simulation. So the student use the software to simulate the circuit running, and they compare the simulation results with theoretical results. If we only offer students the simulation, I don't consider that as a complete lab experience because the students still lack the real hands-on experience that I may have in the traditional brick-and-mortar schools. And on one side, we may not fulfill the ABET accreditation criteria. And the other hand, we are not providing students with the education or the skills that they need. So the focus is on the last one, the measurement or the hardware or the circuit board. So this is a circuit class, circuit lab. So you can see this is a screenshot of one of the videos that we made in the lab course. And when we develop these videos, we assume that the students do not know anything about circuits. And the reason is we have students with different backgrounds, and this is a general education BSc program. So students may have background in mechanics, they may have background in chemical, they may have background in aviation, but they may not have the experience putting circuits together. So we have this mindset at the beginning when we develop the videos. We go very slowly, step by step, show the circuits from different angles so the students know where the wires are going, how to connect the wires to the either MyDAC or Analog Discovery 3, and also explain the expected results so that when students do the labs themselves and they compare with the instructors' videos, and if there are indiscrepancies, they can go back and check their own work. Yeah, next video, please. Yes, and so this is the latest addition to the lab development. So we added this what we call the video assignment. So in addition to the lab report the students have to submit, we ask the students to submit a video to show that they have completed not only the simulation part, but also the hardware measurement. So this is a screenshot of the students showing behind the background is the software with the Analyst Discovery 3 to provide the power output. And you can see the student's own shot that is demonstrating how the wires are connected and so on. So this is one way for us to address the cheating issue, because the students have to show their face and there's no way around. And the other important benefit for having the video assignment is to allow students to practice their communication skills. And that's one big part in our BSc program as well. Normally, before students wait till the final capstone project. When they work on the capstone, they do presentations. But here, even in their 200 level class, they have already started practicing explaining things in technical terms clearly, and I think that's a good experience that they can carry on to the rest of their BSc programs. I think that's it.
Great. Yep, that was the last slide. Well, Dr. Lin, thank you so much for sharing. We are right at the end of our time, but if anybody does have any quick questions, please feel free to put them in the chat. Otherwise, we really appreciate you sharing this with us, Dr. Lin. We appreciate our participants attending. For those of you that are sticking around, we do have trivia starting up in a couple minutes. So if you head back to the lobby, you can join trivia from there. So thank you again to our presenter and participants, and have a great rest of your day.
All right, thank you. Bye.